Hello friends, my name is Ruptikatte and in this video we are going to solve assignments of LP4, that is soft computing and optimization algorithm. First assignment is purely based on fuzzy logic, that is fuzzy set operation and fuzzy relation operation. Before actually starting the assignment, we will see what is the fuzzy set. In any normal set, you can see that whether that element is present or not present. Suppose I want to write a normal set, I will write the set name and the number of elements or name of the elements which are present in the set. But in the fuzzy set, your set may have many degrees of membership. Your elements in the set may be partially present, may not be present, or they belong with some degrees. That's why we call this as a fuzzy set. And here they are represented as a set is represented in a pair of the two elements, that is the name of the element and the degree of membership, means how many percentage it is giving to that particular set, what is the degree of membership. Let's solve some of this operation on the fuzzy set. Let's start coding in the MATLAB. As I don't have MATLAB installed in it in my computer, so I am using online MATLAB compiler. So we will see what is the code for our MATLAB. So first line is CLC. It clears the window. Next, if you want to clear all the workspaces which we have already created, so we will use clear. And if we have already opened some diagram from the previous run of the program, we want to close it, so we will write the closure. Now I just want to print some message, that is LP4 SCOA assignment, so I just use the display function for it. Then to initialize the matrix, I am taking the two matrix for fuzzy set operation, union intersection. Matrix A with values 0.5, 0.1, 0.4, matrix B with 0.2, 0.3, 0.5. Now we will display the matrix value. We will use the display function, single quote for displaying text, and for displaying the values or variable we directly use, or vectors we directly use the name of variable, so display A. In the same way, now I want to perform maximum fuzzy union operation, which is the maximum amount membership among two your set. So it will be A union B, set A union B will be max of AB, that is fuzzy union. So this is my set A, set B, and fuzzy set operation, that is union. So maximum among this 0.5, 0.2, maximum 0.5, 1, 0.1 and 0.3 max is 0.3, 0.4, 0.5 max is 0.5. So in the same way, to perform intersection, we use minimum function, min of two set, that is min of A comma B. So it will give you the intersection, that is minimum among these two membership. It's 0.2, 0.1 and 0.4. To perform fuzzy set difference, it is always, if you perform difference between two sets, that is set A minus B, but in that case suppose set A is having less value than set B, your fuzzy values always lie between 0 to 1. It will never go, membership value will never go in the minus value. So we always perform subtraction of element, comma, which is the maximum element, whether that is going below 0, then we set the value of that with 0. Okay, so it's a maximum of 0 comma A minus B, that is fuzzy set operation. So if we perform the fuzzy set difference between these two, 0.5 minus 0.2, 0.3, 0.1 minus 0.3, that is minus 0.2, but minus membership is never allowed, so we will set it with 0. So in the same way, 0.4 minus 0.5 minus 0.1, so we will set with 0. If you perform reverse, B minus A, so it will be some another value. Now next operation, that is fuzzy complement operation. It's just the 1 minus A. So if you don't want to take the 1, you can also take the function, that is 1's membership. 1 minus this will give you the fuzzy complement. Then fuzzy Cartesian product. Now in the Cartesian product, set A, the value of set A is 3 element and value of set B is 3 element. So in the simple calculation of Cartesian product, you will always get number of elements of set A, that is 3, by number of elements of set B, that is 3 by 3 matrix you will get. So that's why we should calculate what is the row and column of set A. So for that we have used this m comma n is equal to size of A, which will give you the row of set A and column of set B. In the same way, for set B, the rows column will be calculated by x comma y, that is x will be row, y will be column. Now to perform this fuzzy Cartesian product, we will take first element of set A and perform this row. First element will give you the row 1. So that's why I have written the Cartesian product. Now here we will go from 3 by 3. So that's why row is started from 1 to n and column is going from 1 to 1. And also when we are taking individual element, we just taking the minimum among these two. Minimum of these two will give me the first row. In the same way, minimum among these two, minimum among this will give me the second row, and so on. That's why we are written Cartesian product of row and column. Resultant will be the minimum of first row, that is element of first row of set A with every element of set B ka column. This will give me the Cartesian product. And to perform fuzzy max min operation in the same way, we will just calculate the size of. Now here I am not taking simple set, I am taking n dimensional matrix. That is, here my set A is 2-dimensional matrix. It's 2 by 2 rows 3 columns, and set B is 3 rows. Semicolon denotes your rows. Now this is first row, it is separated by semicolon. This is second row, third row. So here this is having 3 rows 2 columns. Now we will calculate the size of our first set, size of second set, that is row 1 column 1. For second set it will be row 2 column 2. As we want to perform matrix max min composition, we have to calculate row 1. Our final product will be row 1 by column 2. That will be our final column. And also if column 1 and column row 2 means the column of first set and row of second set are matching, their size is matching, then and then only this composition will be possible. So this is the case if they are matching, just like your matrix multiplication you do in mathematics. So if their dimension is matching, we will go for the calculation. Now first row, our resultant matrix will have only the size of row 1, that will be rows, and size of column will be that many columns. Now what I want to perform, like here we will take, in this we are performing max min, and also from all of these we are again going to pick the maximum elements. That's why what I am doing, I am calculating max min from each row with respective column, and again from that also I am again computing the minimum, the maximum, all from all the minimum I am taking the maximum value. So that's why I have written this function, that is previous of 1 will be calculated with first previous of 1 will be set to 0. Now next time what we will do, we will calculate this, we will calculate 0.5, 0.2. What is the minimum value in this? That is 0.2. Now for the next run, previous one will be 0.2, set to 0.2. For the next run, our cursor will move at this particular place. So for this 0.1 and 0.3, what will be the minimum value? That is 0.1. This will be calculated. For this 0.4 and 0.5, minimum will be calculated, that is 0.4. Now among all of this, our minimum, from all of this minimum 0.2, 0.1 and 0.4. Okay, now we have to calculate maximum. So that's why I have written this additional I have written. So from all of this minimums you are calculating, so you will calculate the maximum value. So it will give you the maximum composition. And if you want to perform max product composition, instead of calculating minimum, so you can go for calculation of the product. So this is, and display the results. Thank you users.